Hello, and welcome back to the video lecture series for Introduction to the Art of Programming Using Scala. We're going to continue our look at object orientation in this video. In particular, talk about visibility settings and the separation of interface from implementation. So, one of the big challenges with software development is that software has the ability to become pretty much arbitrarily complex. Given the capabilities of modern computers, your limits on what you can create, the closest thing to a limit is how much your programmers can type in. And that's not much of a limit if you hire enough people. The problem is that if you keep making software bigger and bigger and bigger and you're not very careful about it, it starts breaking, it becomes brittle, and it doesn't work very well. And so we are constantly looking in computer science for ways to simplify this complexity, to deal with complexity. And actually, object orientation has been one of the more successful ways of dealing with complexity that's been developed so far. And so object orientation really starts to stand out when you're dealing with large software. And a big part of the advantage that you have is the ability to hide things. So let's look at an example of this. Let's make a bank account. And I'm going to create a class in here called an account. And the account has, I don't know, person's name as a string, a balance, we'll use a double, and sure, we'll make this a really simple bank account. Def description is going to give us back a string, and it will just be name plus $sign plus balance. It's not necessarily ideal. Well, we'll go with this for now. I guess we'll decide how we want to clean stuff up. And things you can do with a bank account, for example, you can make a deposit, and so your deposit can be a certain amount, also a double. And what happens when you make a deposit is that the balance is incremented by the amount, and when you do a withdrawal, it's decremented by amount. Okay, so this is kind of a first shot that we might write down. We have our account, it has a name and it has a balance, and we've added 3 different methods inside of here. This won't work, but it's very helpful to see why it doesn't work and what needs to be changed. So first error, assuming we don't have typos, that we get, is right here. And this says reassignment to val, which basically is that when you pass something in as an argument, it's treated as a val, though as we saw last time, it's not the same as a val member of the class, but it still can't be altered. So this is somewhat problematic for us. And the way this is written, this account needs to be mutable, so we can make that as a var. And now this code actually compiles. So let's say I want to go ahead and create a balance, or create an account. Account equals new of account, and I'll set it up for me. And it has all of $1 in it. Okay. Print line description. Make sure that is happy. Whoops. Print line account dot description. Note that I didn't have the description do a print. In general, it is more flexible to return a string so the outside code can print it than it is to print it inside of there. You could choose either way. Didn't put in a space. That might be a good thing to do. Clearly, you can see there are some challenges here with my balance, like for formatting this as money, we'd typically want 1.00, and I didn't get that. Let's do something else. Let's say that I have this and account dot withdraw. Count dot withdraw 0.9. We'll pull out 90 cents. And then we'll print our account again. And you see here, this is a little bit of a challenge. And what's more, I guess, let's put a function so we can check def is empty. So if you withdraw 90 cents and then you withdraw 10 cents, and we started with $1, if account dot is empty, print line, all money gone, else print line, still got some. Hopefully that bothers you. We started with $1, we pulled out 90 cents, and then we pulled out another 10 cents, and apparently this says we still have money. Okay, well, how much money do we have? This part's actually going to be even more disturbing. We have negative money. It's a really tiny amount of money. This is in scientific notation. This is saying this is times 10 to the minus 17. So it's 0.000000000277, negative of that. So now we didn't put anything in here to check to make sure that you couldn't go negative. In fact, maybe that would have been a good thing to do, to have it so that we can't withdraw more money than we have. Turns out, had we done that, this line right here wouldn't have done the withdrawal. And you might recall from way back in chapter 3 that the reason for this is because doubles are not the real numbers in the sense of mathematical real numbers. They have a finite precision to them. And so we saw the fact that, for example, 1 minus 0.9 is not the same as 0.1. And you can see that right here. And so when we subtract the 0.1 off of it, we get a slightly negative value because of just the way that this works. And so let's assume that you had been writing your code for a while and you had done something like this. And then after a while you realize, oh my goodness, I should not have represented money as doubles. Okay, which, general rule, never ever 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 represent money as doubles. It's a bad thing to do. How should you represent your money? Well, you should really represent your money as an int, where it stores how many pennies you have. For example, if it's American money, you pick your lowest denomination and you make that your base for your int. What happens if I were to change this to just an int? Now, in the code that I've written here, well, actually, I'll have some problem. Let's see. Because these are now ints in pennies, I start off with an account balance of 100. First time I withdraw 90 cents. Second time I withdraw 10 cents. Okay. Yeah. So that seems, reasonable. But it's I had to make quite a few changes in here. Okay. If I had realized this later on after a whole bunch of code had been written, I would not have wanted to make all of these changes down here at the bottom. You know, if I had lots of lines of code, thousands of lines of code that assumed that these things were doubles, I would have a problem. Okay. But because basically I have locked myself into using double here. So I said that this video is about visibility and the separation of interface and implementation. Everything that you put into a class that is public, that is visible, is part of this public interface. So the fact that we can call deposit, the fact that we can call withdraw, the fact that we can call description from outside of the class means that these things are public. We have public access to them. Any piece of code can access these things. And the problem here is that when you start everything that you put in as public, once you've written much code, it kind of gets fixed into place. Because if you change the things that are public, you know, if I change amount from a double to an int, all of a sudden I have some significant problems in here. Now, the other thing that's problematic here is the fact that I have given the ability for balance to just be a var. And really, this should have some code so that, for example, when you do a withdraw, let's make it so our withdraw returns a Boolean. So it'll tell you whether or not it worked. If amount is less than or equal to balance, then what am I going to do? Well, I'm going to return that. Or I'm going to subtract off, and I'm going to say true, else false. Okay. It might also be nice just you're not allowed to make negative withdrawals. In the case of deposit here, you're allowed to deposit anything that you want as long as it is non-negative. And I will also put in a return type here. There are other ways of dealing with this that we will learn about and start doing later on. We've seen brief glimpses of using exceptions, and that would be kind of the alternate approach, probably a more proper approach for this, so that if instead of just returning true or false, you throw an exception if they do something bad. Depends upon the way in which the code is structured. But okay, so now we have some checks in here. The real problem with so the real problem with balance being a var is it turns out that these checks that we've made actually put a safeguard on our account. So if once you create a new account, you should never be able to make the balance. I don't know. Okay, I was thinking maybe we should have made it so you don't pass in a balance and you just have to do a deposit to start with. I don't know. We could definitely change that, but by having this balance as a var, and this var is publicly visible, which is why I was actually I didn't do anything down here, but I have the ability to access the balance. So the way this code is written right now, and let's print it. Okay, and now we run. Oh yes, we have a type mismatch where it doesn't like our balances being subtracted off from doubles because I changed our balance to an int. Let's go ahead and let's go back to a double, because we'll take this in 2 steps. So first, as a double, well, we know we have a round off error, but this line right here should probably bother the heck out of you. the balance on an account is probably not something that should just be set anywhere. There should be some protection on the balance. And that's what visibility allows you to do. So Scala has three basic types of visibility. By default, you get public. If you just write a def or a val or a var or any declaration inside of a class, that declaration becomes public, which means that any code can access it. In this case, anyone, any code, anywhere that gets hold of an account can change the balance, it can call description, it can call deposit, and it can call withdraw and is empty. Okay, they are public, and that is the default in Scala. But especially for data values, in particular for vars or for a val to a mutable data type, you generally want to hide those away, and part of the reason is shown here. Not everything should be allowed to edit the account balance. So how do we fix that? Well, we use another visibility. I'm going to make my balance private. Now let's see what happens when I do that. I'm going to get some errors. This line right here that says set it equal to -999, I'm not allowed to do that anymore. You're not allowed to just set the balance because now the balance is private. And that's a good thing, because I really didn't want just any part of the code to be able to set the balance. So we were able to kind of put a safeguard in there. As a general rule, if you have something that's a var inside of a class, it should be private. There are going to be exceptions to that, and there are ways of getting around that. But you're just like by default you should make things vals instead of vars. By default, anything that is a var inside of a class should be private, unless you have a really good reason to make it public. Okay, now it turns out this has some other benefits for us too, because when it was public, people could have written code that actually directly utilized balance, and that code that utilized it might have cared that it was a double. Okay? It might have actually done something with it where it assumed that it was double. In fact, the simplest way to do that would be if I undelete these two. Okay. This line right here assumes that balance is a double because it's setting it to the value of a double. And if I were to change it to an int, because we realize, oh my goodness, money should not be doubles, then this line would have a problem, and we still have problems up in here that we'll fix in just a second, but even just this line would have a problem. By making it private, we don't have that problem anymore. We've kind of sectioned it off to the side and made it so that not everyone can deal with it. The other thing that making this private will allow us to do is, because no one has been able to play with it, we can change our implementations inside of here so that they work just as well with the double. And what I want to do here is say that the balance should be incremented by that times 100.to int. And then I'll do the same thing down here. Clearly, shortcuts were not so happy for me. Okay, so does that fix our problems? No, because so this is I would really like for this code to work down here unmodified. As it's written right now, I have to go to pennies for that, and we have this, which in some way, well, this is good. It did what we wanted. I start with 100 pennies, but then I'm using doubles in here, but doubles are being converted to ints up in here, so that before it does the math, it takes a double and converts it to an int. And while that might not be ideal necessarily, it is far safer than what we were doing before. And if we had a large amount of code that included doubles like this, this would be a superior approach for us to work with. But I don't even want to have to change that line. Okay. So what can I do in that case? Well, the reason why we saw last time that the arguments that are passed in are by default are neither vals nor vars. They're not actually members. They're not stored. So what I'm going to do here is I am going to make, that's not a star, I changed the name of the thing we pass in to just val, okay, short name, and it is, I'm actually make it so it's not an integer. This one really is a double, okay. And then inside of here I'm going to make a balance, and if I just left it like this, it would be public. I don't want it to be, I want it to be private. And so because this has the call toInt, that balance winds up being an integer, but when we construct it, we can pass in a double. So this gives us the behavior that we want. We don't have the rounding problems of doubles because everything is converted to an int before any math happens on it. And at least, you know, that makes me significantly happier. I might create an addition, put in two other methods, deposit int and withdraw int. But the thing to keep in mind, this private right here, it allows us to hide stuff away. We do this pretty much all the time with anything that's a var. We'll learn later that there are ways that you can possibly get around that in Scala and not have it bite you too bad. Your methods are often going to be public, which means that we don't have any modifiers on there, but it is quite, there are quite a few times when there are methods that you write and no outside code needs to get hold of them. They're just helpers that are used inside of a class, in which case they should be private. There's a third type of visibility called protected that we'll talk about in a few chapters. You have to talk about inheritance before that will really make sense. But your kind of simple rule of thumb at this point is that any method that needs to be called from the outside is going to be public. All vars should generally be private. And the arguments that you pass in, you can pass in something that is of a different type or whatnot, and then do a conversion on it, but so that you don't necessarily have to make this a val or a var, and it doesn't have to be remembered. This val literally can be thrown away from the account. The account doesn't need to remember it. So this idea of the separation of interface from implementation is that I would, in an ideal way of writing the code, this stuff down here doesn't change even if I make alterations up here. So that you want the programmer to program to your interface, which is to the kind of description of the public methods. Withdraw takes a double. Deposit takes a double. They write their code just assuming that that's going to do the right thing. They don't know what it's going to do, but as long as they make the assumption that deposit's going to add money and withdraw is going to take out money, your code is going to work well for them. And if you change things in the background, you can change things that are private. That's the implementation part. That shouldn't break the behavior of the code. And if you keep those well separated, it makes it much easier to grow large programs. So our next step here is just you can hide things away inside of your class. And in fact, you should do this. Make things that the outside world doesn't need to know about, make them private so that the outside world can't get hold of them, and especially in the case of ours, can't mess them up from you. So that's it for this video. We will come back and we will look at some more details of classes and write some interesting classes in the next video.